outcomes of this lesson are to show examples of everyday usage of the word energy, to distinguish the abstract meaning of the word energy in science as opposed to its everyday meaning, to show examples of how to elicit learners' misconceptions on energy, and to suggest the development of understanding of energy through its key aspects rather than definitions. Energy is a common concept. We use it widely in everyday language, but in the everyday language, energy does not have a unique meaning. It is used with a variety of meanings. For all people, energy may be associated with being young, fit, and lively. Spooky houses may be seen to have negative energies. This is associated with good or bad vibes, or even the supernatural. Energy is considered a commodity which can be consumed and finished. Energy is confused with fuel or a kind of substance we put into an engine. Energy is perceived as a flowing substance which can be felt by our senses.
Now, in science, we measure energy purely in terms of work done on or by bodies. But we cannot really say what energy itself is, except that we use the concept whenever something is changing.
It is this abstract notion of energy that causes much confusion in the learners. From an early age, they carry a whole range of ideas about the world and how and why things behave the way they do. These ideas are prominent and difficult to change and may affect negatively the learner's efforts to understand science. So how would teachers overcome this problem?
It's a concept which really can only be grasped very gradually. Teachers have got to have patience and present the learners with a lot of different examples of energy. And I think it's through the examples and the conversion of energy from one form to another that gradually the concept is grasped.
Along those lines.
In this video, we show 2 classroom strategies the teacher can use to bring learners to a closer understanding of the scientific notion of energy. In the first case, the teacher will use worksheets and discussions in groups to probe about learners' prior or current knowledge of energy. And secondly, using experimentation, observation and discussion in groups, the teacher will prompt learners to come to a more scientific understanding of energy. At Rashoma High School in Soweto, the teacher Anthony Mogale is introducing his learners to energy.
We wanted to see what are the learners' perception about energy and its associations to our everyday lives.
And the best way to uncover possible learner misconceptions is by giving them an opportunity to discuss and talk about it and carefully listen to them. Activity 1. Establishing prior knowledge. In this activity, the teacher gives the learners a worksheet showing a diagram illustrating a situation. The worksheet includes a set of questions relating to energy and energy transfer. The teacher requests the learners to discuss these questions in small groups. He then carefully listens to their arguments and makes notes or a list of their ideas.
But then because it's told, say, this has potential energy, say. It has a potential to do something, and that something is it can melt, say.
My involvement was such that I should probe the learners but not give them answers. If they were having an argument, I could only probe for clarification purposes, not to say whether the answers are correct or incorrect.
You can see that the snowman also gets the energy from the fire.
Well, when ice is melting, does that mean it receives energy?
Yes. It cannot melt by itself.
It cannot melt by itself.
It needs the energy from the fire to melt.
In this group, the energy transfer is associated with the movement of the water and not with the phase change.
Yes.
The teacher moves between the groups.
The stored energy from the fire is converted to the kinetic energy, where the snowman melts.
So there is stored energy in the fuel.
Not from the fuel. The fuel is...
The fuel itself...
In this group, fuel is viewed as stored energy. In this picture, a tin of paint stands on top of the ladder.
The man has more energy because he will be able to climb
the ladder. He will exert energy on this tin, and then the tin, when it falls, it has a potential energy until it reaches up the ground, whereby it has a kinetic.
A strong view in this group is that the painter has energy because he's alive, while the tin on top of the ladder does not have energy because it is a non-living object. Furthermore, energy is confused with force. In another picture, hands are being heated in front of an electric heater.
You can feel energy.
Energy is perceived to be warm and can be felt.
And energy is the ability to do work. And if work has been done, that means your energy has been given off. And force is involved.
In this picture, water in a bird bath froze at night.
As the water freezes, it gains energy. Is that true?
No, we don't.
You don't agree?
Energy
Why?
is transferred from the form of being liquid to ice, to freeze.
Liquid water and ice, they're the same substance. Now, do they have the same energy?
The frozen one has more and liquid has less.
Liquids and solids are perceived to have different types of energy. By the end of this activity, the teacher has become aware of the existing ideas of the learners and has accumulated a list of misconceptions.
The learners thought that the energies was something that they could see, maybe that they could feel. Like if they encounter a hot environment, they would think that energy is responsible for the hotness in that environment. You had some referring to fuel as being energy itself.
How do teachers resolve learner misconceptions?
I hold the ball some distance above.
Through discussion and experiences with the learners, the teacher will lead them to a more scientific understanding of energy. What is energy?
We cannot really say what energy itself is, except that we use the concept whenever something is changing. It was introduced during the 19th century when people were studying heat and they needed to keep tabs on the changes that a system could undertake. In any process, if we analyze the situation in toto and look at different parts of the system, what we can say is that any loss in energy in one place is compensated by a gain in energy somewhere else. We can do our sums, and what we know is that the total of all the energies must add up to a constant fixed amount.
This is much like the concept of money today. Money in society is very much like energy in nature. When they transfer, they both cause changes. And money today is a very nearly abstract idea represented by numerical figures in our account statements. Most transactions happen electronically, that is, by adding or subtracting figures. Yet every cent in our account must be accounted for. We want to know exactly what money comes in and what goes out and why. Because energy is such an abstract idea, introducing it by definitions is not going to contribute much to the understanding of learners. It is advisable to begin with the way scientists use this idea rather than what it is. And of course, the underlying notion in all events in nature is that changes happen only while energy transfers from place to place or from object to object.
A stone which is at the top of a hill, given a little bit of push, it will roll down the hill, and there's obviously been a change. The stone has started to move, so we say, well, let's give that movement a name, and we call it kinetic energy. Now, that kinetic energy could only have come from something else, and that something else is simply the energy which the stone had by virtue of the fact that it's at a place in the Earth's gravitational field, and we call that potential energy.
Activity 2. Prompting learners towards a more scientific understanding of energy. In this activity, the teacher uses physical objects for experimentation, observation, and discussion. Each group of learners is given an activity involving a change. This change must be observed or analyzed in terms of energy transfer.
All of your observations will have to be divided into 3. the beginning of the event, the middle of the event, and the end of the event. At each and every stage, there should be some energy associated.
The learners discuss these energy changes in their groups before reporting back to the class on their findings. In the first example, a marble is rolled down an incline and comes to a stop.
We now know where the last stage is. Where is the first stage?
When the ball is on top of an incline.
It is important to stress to learners that the 3 stages of the event are defined by the participants in the group. There are no definite starting points.
What is of utmost importance is that energy can be associated with each and every stage, because there is energy in each and every stage.
This was our first stage where the ball was stationary and it had potential energy. Then this was our second phase where the ball was moving and had kinetic energy. And at last, where the ball had stopped and it had gained the potential energy.
The teacher will prompt learners to accept the notion that energy is not used up or lost, but that it dissipates to the surroundings. In another group, a battery was connected to light bulbs.
Okay, our first stage, we haven't connected this red wire to the other side yet. And then energy is still in the battery. And then our second stage, we connect the red wire to this other side. And then the energy from the battery is transferred to the bulbs.
During the report back, the teacher will guide the discussion with directive questions.
If we leave this connection like this for a week, what will happen?
The bulbs will stop glowing.
What would have happened to the energy of the cell?
It transferred to the bulbs.
Feel the bulbs? Is it hot?
Yes.
After a week, the globe stops glowing. What happened to energy?
The energy will be lost to the surrounding.
And how will you know that?
The heat will be no longer there.
The heat will no longer be there. Okay.
Through this discussion, learners are becoming aware of energy transfers. In this final experiment, a marble is rolled along a channel so that it will hit 3 other marbles.
Our first stage is when we push this marble. The middle stage is when this transparent marble touches these 3 stationary marbles. And our final stage is when this marble moves in the opposite direction.
I mean, this marble strikes this one, but this marble ends up rolling. Why not these 2 marbles involved in motion as well?
As this marble transferred energy to this one,
right.
This one also transferred energy to this one, therefore it contained no energy. And this one also transferred energy to this one, therefore it also remained stationary. This one moved with the energy.
What type of energy was transferred?
Kinetic energy.
Kinetic energy.
Although coming to an understanding of energy is a slow one, by physically demonstrating these activities, the learners have had a chance to see and talk about how changes happen while energy transfers.
We expect the learners to understand that energy changes from one form to the other. That when an object has lost energy, it doesn't mean that energy is lost for good. That energy has been transformed from one phase to the other. If it's being lost by the other objects stand a chance of gaining it.
It is evident that learners might memorize scientific definitions and formulae, but their own intuitive ideas on energy persist up to the end of their schooling.
Hello, we have Mike from the School of Physics at WITS, and then we have Andrew from Protect, a well-known NGO. Now we've seen the video, gentlemen. We have been observing a teacher teaching the topic energy, and the teacher have used 2 specific strategies. He has used the strategy of supplying worksheets to the learners, and then later on he actually asked the learners to to do some experiments. And do you, in your own experience, find the teaching of the topic energy difficult in schools? Mike?
It's not an easy topic, basically because the concept is very abstract. And to try and make it alive for learners, the teacher must use real examples. And I think it's important for the teacher to think carefully about the examples that he or she chooses. But I think that in the video, I think the teacher used some very nice examples, and I think the strategies came across very nicely.
What do you think about the strategies that the teacher used in the video?
Yes, I think, Tembi, that the strategies were excellent. You know, the use of the worksheet with something that reflects things that learners can relate to in their everyday lives is really fantastic. Snowman is not a very common thing in our everyday experiences, but I think it's something that learners can relate all the same. And I think the teacher showed sensitivity to the fact that this is a very difficult topic. I found it extremely difficult. I still find it difficult to teach the topic of energy, you know, but I think his strategies were good strategies. Yeah.
Looking at the first strategy where the teacher used the worksheets, sometimes it becomes difficult for teachers to be in a position to use photocopies and stuff like that. In most schools in South Africa, they don't have such equipment.
If the worksheets create some difficulties, then what the teacher could do is simply use a blackboard or a sheet of paper just to do a drawing of some instance where energy is, where an energy change is taking place, and use that as a focus for discussion. Or he could involve the children in some sort of activity and get them talking around that. In the video, the teacher encouraged the children to talk, and as they talked, their various conceptions and misconceptions about energy came to the fore. That was very, very nice. And so the teacher was finding out what the learners already know, and that is the important first step.
Do you think the same?
Yes, I would come from the same school of thought, Tembi. I mean, the fact that learners are not coming to the classroom as empty slates, you know, to be filled or completed. They bring with them experiences, they bring with them certain understandings of everyday phenomena. And whether we want to call them misconceptions or alternative conceptions, the fact is we need to use those as a baseline or springboard, if you like, to be able to make inroads so that at the end of the day, the concept, very difficult an abstract concept, can actually be precipitated in the minds of the learners.
When looking at the second strategy, where the teacher had to involve the learners in experiment, and I think that is very important when you look at the scientific process, where we have to look at the scientific skills. How did you find that handled in the video that you have just seen?
Well, the teacher handled that in a very, very appropriate way. His experiments were simple in the extreme, but they illustrated very, very important physical principles. So, you know, just rolling a marble down the groove in a plastic ruler was excellent. And, you know, that doesn't require any sophisticated apparatus at all. Just, you know, marbles and rulers, and then he used a ball at the end of a piece of string, in other words, a pendulum, illustrating the interchange between potential and kinetic energy. And that is a marvelous demonstration. The pendulum you can use over and over and again to illustrate all sorts of interesting physical principles.
I actually like the stage where the teacher had to use the pipe and say first stage, middle stage, and the final, because that's very important in the teaching of the term, of energy.
One of the strategies that we found very useful is the POE approach, which is predict, observe, and explain, you see, which I didn't quite see the teacher use. I mean, it's not a must-do, but I think it's something that is good to reflect on, because what it does is you ask the learners first. If I have the pendulum here, you know, if I pull the pendulum bob up to that point and let go, what would happen? You know, before you actually do it, and then just elicit some responses from them, and then do it, and then get into engaging or negotiating meaning through explanation and discussion.
Now we have two things. We have the teacher using the everyday material, and then we have the conceptual development. How do you go around developing the concept from the everyday experiences of the learners to the actual scientific concept?
Just again, a simple example would be to take their household and let them report back on how and where energy is used within their everyday living experiences. So there's the, well, the household may or may not have electricity. If it hasn't got electricity, then, you know, they must talk on in how did they heat the water up? How long did it take? What was the most efficient way of heating it up? And to report on the changes that they observed while that was happening. I think go via something they know. So we could use the ordinary household, or a car, for instance. We could just study or ask them to comment on the physical operations, what they think is happening inside a car. The teacher can take them out into the school car park and open up the bonnet of the car and start the engine going and talk about what is happening there.
So you're bringing in here a very important point of the learning cycle.
Yes.
Where you're actually taking the learners at the level where they are.
Yes.
And then develop it through the everyday experiences. And then from there introduce the concept, the new concept that you'd like to introduce.
You've got to start from the concrete, you know, and the concrete here being what learners know, everyday experiences, you know, and also the concrete being where actual things that are within the environment, like the car.
In some cases, there are some misconceptions that they encounter on their everyday experiences, like on TV adverts, where they talk about energy is strength or energy is this, etc. And those create some misconceptions. Or as a teacher, then how do you go around those misconceptions?
You know, there is nothing that the science teacher can do about the way in which the word is used on TV or radio or in the newspaper. But I think that what part of our science teaching involves learners learning the vocabulary of science. So the science teacher needs to encourage learners to speak correctly about scientific concepts within the classroom. So I think it is, and again, perhaps the teacher, as an exercise, can send learners, once they've started to talk about energy, can actually send the learners out and ask them to report back on where they had heard the word energy used, and to then work out whether the word was correctly used or incorrectly used. So in a sense, using misconceptions or alternative conceptions to get rid of alternative conceptions.
Thank you very much, gentlemen, for your contribution. Unfortunately, that's the only time we have for today, and thank you very much.
It was my pleasure. Thank you.
Pleasure.